Okay, so this is question 2. So I haven't drawn the diagram. First thing I'm going to do is put all of the forces that are needed. So we've got our normal reaction, we've got tension, tension, tension. We've got our frictional force acting down the plane because this particle is moving up the plane and this one is moving down. Put our perpendicular to the plane angle in for our 2 mg force. Okay, so now we're going to fill the table in. This is particle A and particle B. So for particle A, going up, we've got T, perpendicular normal reaction will have no effect up the plane. We've got minus mu times r down the plane, and then we've got minus 2 mg sine alpha. Because we've got tan alpha up here, so sine alpha will be 3/5 and cos of alpha will be 4/5. And we also know that mu is equal to 1/4. So up the plane, we've got movement, so it's ma, which will be our resultant. And then perpendicular to the plane is in equilibrium, and our forces perpendicular will be T's got no effect, R obviously perpendicular, no effect for the friction, and then we've got minus 2 mg cos of alpha perpendicular to the plane. Now if you look at what's going on with B, it's moving down, so it would be minus T and then 4 mg, and that obviously that resultant is equal to ma. So dealing with B first of all, for our Newton's second law, resolving down, we would have 4 mg minus T is equal to 4 ma. I'll call that equation 1. And then for our particle A, we would have perpendicular to the plane. We're going to have R is equal to 2 mg cos of alpha, which is 2 mg times 4/5, which is 8 mg over 5. Resolving up the plane, we would have T minus mu r, which is 1/4, 8/5 for r, mg, minus 2 mg 3/5, and that's going to equal 2 ma because our force, because our weight is 2 mg. So then we need to simplify, so we would have T minus 2 mg over 5 minus 6 mg over 5 is equal to 2 ma. So T minus 8 mg over 5 is equal to 2 ma. I'll call that equation 2. So, in order to find my acceleration, I'm going to eliminate T, so I'm going to add equations 1 and 2. So add 1 and 2 together. So I end up with 4 mg minus 8 mg over 5 is equal to 6 ma. So A is equal to, so that's 20/5 minus 8/5, which is 12/5, divided by 6, which will be 2/5 g, because the m's all cancel. So that's part A. Now in order to do the next bit, we need to think about what's going on here, because when it says particle B doesn't rebound when it hits the ground and A continues moving up the plane, what actually is happening is that B hits the ground and A moves up the plane a distance h, and that distance h is with tension. When this hits the ground and this moves up h, as soon as it gets to this point, then it travels a small amount with no tension and then stops. So this point here is the y, this point here is x, and this point effectively is when B has hit the ground. So we know that is h, and we know that's travelled that distance with the acceleration that we just found. But this last portion here is going to have a new acceleration that we're going to need to find. So what we need to do now is we need to do suvat for B. We know it starts at 0. We know it's moved down h, so it hits the ground here with some velocity, and that velocity will be then our new u for our last portion. Okay, so if we do suvat here, we would use v squared equals u squared plus 2as. So we've got v squared is equal to 0 plus 2 times by 2/5 g times by h. So my v squared is 4/5 gh, and I'm just going to leave it in that form. So now if we look at what's going on the plane, it started, if we say this is our g, so we've got our u, which is our vb from over here, and then it's stopping there. We've got it moving here, and the only forces acting on it up the plane are going to be the weight component and mu r. So we can find our new acceleration here, which is going to be a deceleration, of course. So then we will say minus 2 mg sine alpha minus mu r, which we found before and was a quarter of 8/5 mg, and that's equal to our 2 ma. So minus 2/5 mg, should have done this already, never mind. Minus 2 mg over 5 is equal to 2 ma. So we've got minus 6, minus 2 is minus 8, minus 8 divided by 2 is 4, so my A is going to be 4/5 g, because all the m's cancel. Okay, so this new acceleration now we can use to find out what this distance is here. If we call that d, because ultimately we need to add that d to this h to find the total distance xy. So we can now use this a for this last portion of the motion. So we've got gy, I'll call this bit g here. So we would have v squared is equal to u squared plus 2as, where this s is my d in my diagram. My v is 0 because it stops. U is my VB, so I can leave this in this form. So 4/5 GH plus 2 lots of, I made a mistake here, that should be a minus obviously, minus 4/5 G, and that's times by D. So my distance D is going to be 4/5, G's cancel, H divided by 8/5. which is equal to 0.5 h. So therefore, the total distance xy is going to equal h plus 0.5 h, which is 1.5 h. The first part of the question, in my usual form, didn't answer. Reason why the magnitudes of the acceleration of the two particles are the same is because the string is inextensible.